It says let the function f r to r be defined by fx equal to, the function fx is given as x cube minus x square plus x minus 1 into sin x. So if I take x minus 1 factor common, it will be x minus 1 into x square plus sin x. This is the function fx. Now some initial observation, you can see f of 1 is equal to 0 for the function, f1 equal to 0. And you can see that this is a linear function, so which is continuous and differentiable. X square is continuous and differentiable, sin x is continuous and differentiable. That means we can safely say that the function fx is continuous and differentiable at every values of x, and f1 is equal to 0. So these are the initial observations. Now another function gr2r be an arbitrary function, and we are defining the product of the two function f into gx as fx into gx. We are defining product of two function fx into gx, where fx is this function and gx is another arbitrary function. Now we have four options we need to test. First option is if g is continuous at x equal to 1. Let us see the first option. If g is continuous at x equal to 1, that is limit h tends to 0, g of 1 plus h is equal to limit h tends to 0, g of 1 minus h is equal to g1. This is the condition of continuity at x equal to 1 for g. So this condition holds, then f into g is differentiable at x equal to 1. So let us test for differentiability of f into g. So for f into g to be differentiable, what is the condition? The left hand derivative and right hand derivative should exist finitely and they must be equal. So let us see the LHD of f into g. So LHD of f into gx at x equal to 1. So LHD of f into gx at x equal to 1. Now first of all, what about the continuity? For continuity, you see f is continuous already at x equal to 1 and g is also given to be continuous at x equal to 1. So the product f into g must be continuous at x equal to 1. Next, what we are going to test is the differentiability. Now what is the left hand derivative at x equal to 1? So that will be equal to limit h tends to 0, f of 1 plus h into g of 1 plus h. I think left hand derivative will be 1 minus h. So it will be f of 1 minus h into g of 1 minus h minus what is the function value of f into g at 1? Of course, f1 into g1. This value must be equal to 0 because f1 equal to 0. So function value at x equal to 1 for f into g is 0. So minus 0 divided by minus h. So I can rewrite this limit as limit h tends to 0, f of 1 minus h minus f1, because f1 is 0, by minus h, and let me split it into limit h tends to 0, g of 1 minus h. I have split it into two different limits. Now you can understand that this is nothing but LHD of fx, LHD of fx at x equal to 1, and this is LHL of gx, LHL of gx at x equal to 1. Clear? I have split it into two limits. This is the LHD of fx at x equal to 1 and this is the LHL of gx at x equal to 1. Now here I have subtracted the term f1 because it is 0, so it will remain the same. Now you see that we already know that fx is differentiable at x equal to 1. That means this value LHD is a finite quantity and function g is also continuous at x equal to 1. That means this LHL value should be equal to g1, which must be a finite value. So this is finite and this is finite. So this is a product is a finite value. And if we go for RHD of the function, RHD of the product function f into gx at x equal to 1, that will be limit h tends to 0, f of 1 plus h into g of 1 plus h minus function value at 1 is 0 divided by h. So this one also I can split it like this. Limit h tends to 0, f of 1 plus h minus f1 divided by h into limit h tends to 0, g of 1 plus h. So you see that this one is the RHT of f at x equal to 1, and this one is the RHL of g at x equal to 1. Okay. So again, RHT at x equal to 1 of fx should be finite because it is differentiable, and RHL of g at x equal to 1 must be finite because it is continuous, right? So what we can say is that this is finite into finite. So this is finite, finite into finite. This is finite, and they must be equal also. Because fx is differentiable at x equal to 1 means LHT equal to RHT. Gx is continuous at x equal to 1 means LHL equal to RHL. So this product and this product must be equal. What does it mean? That LHT and RHT of f into g must be equal at x equal to 1. So f into g must be differentiable at x equal to 1. So first option is the correct option. If g is continuous at x equal to 1, then f into g is differentiable at x equal to 1. Now you see there is a direct connection with option C, that is if g is differentiable at x equal to 1, then f into g is differentiable at x equal to 1. We can easily say this option is correct if we have already proved first option is correct. Because you see that if g is differentiable at x equal to 1, what does it mean? G is continuous at x equal to 1. If a function is differentiable at a point, then it must be continuous at the point. So if it is continuous at x equal to 1, we have just proved that if f into g is differentiable at x equal to 1, that means option C is automatically correct along with option. Now let us come to option B. Option B is saying if fg is differentiable at x equal to 1. Now it is saying the reverse. If it is given that f into g is differentiable at x equal to 1, what does it mean? That means LHT and RHT, these two values are equal. Okay, these two values are equal. Then g is continuous at x equal to 1 means now this is not given, but what is given is that this product and this product are equal and finite. What we can say from here, this product and this product, they are equal. It is given. Now out of that LHT of fx and RHT of fx, that is already same because fx is differentiable at x equal to 1. What does it imply? That means this value and this value should be same. That means LHL at x equal to 1 and RHL at x equal to 1 for g must be same. That much we can say. But LHL equal to RHL does not ensure continuity, right? Because LHL equal to RHL equal to the function value, then only it is continuous at x equal to 1. Okay, so if it is given that only f into g is differentiable, that means it is given this product and this product is equal. From there what we can conclude? We can only conclude that this limit and this limit are equal. That is LHL equal to RHL. But we cannot claim that LHL equal to RHL equal to function value. The function value can be different. Because we are treating with some arbitrary function, the function value can be something else at that point. So this option is not correct. We cannot say that g is continuous at x equal to 1 because g is an arbitrary function. We don't know what is the function value at x equal to 1. And if option B is wrong, automatically option D is also wrong because if fg is differentiable at x equal to 1, then g is differentiable at x equal to 1. We cannot say that the function is continuous at x equal to 1. Then of course we cannot say that the function is differentiable at x equal to 1. So option D is also wrong. Option A and C are correct.